Okay, hey everyone, welcome from the Ethereum Bazaar. My name is Shyam Sridhar. I'm a research intern at the Robust Incentives Group, which is a research team at the Ethereum Foundation. And today I'll be talking to you all about some really fascinating and cool stuff like reinforcement learning, proof of stake, consensus, and the Ethereum blockchain. And all of this is based on a project done in collaboration with my wonderful supervisor, Barnaby Mano. Really grateful to be here in front of all of you. And without any more delay, let's just jump right into it. Here's some really cute unicorns. Okay, so the first question we really need to ask ourselves is, what is reinforcement learning? What exactly does this word mean? So if you ask famous researcher Steve Burton, he actually defines this term as a framework for learning how to interact with an environment with experience. So this is actually very much inspired by nature. This is how animals learn things. They go through the trial and error method of doing something, seeing the consequences and learning from it and subsequently improving it. But what exactly this entire textbook definition really boils down to is this, that the entire framework can be described as an interaction between an agent and an environment. So in this interaction, the environment is actually presented to the agent in the form of a state. So for example, if you want to train an agent how to play the game of chess, this can simply be the position of each piece in the chessboard. Next, the agent gets to have some amount of influence over the environment through an action. The action in our chess example can be anything like moving a piece on the game board as per predefined rules of chess. And now before the next state is presented itself to the agent also receives back what you get as a reward. So this reward can be something like the number of opponent pieces the agent knocks out of the game, or just about anything that returns a positive value to the agent every time it is closer to winning the game. So essentially, through this interaction, the agent gets to now devise a policy for every given state action pair in order to maximize its rewards. Now, this sounds simple enough, right? So what exactly are its applications so far? And what are some of the really cool and amazing things that RL has been able to achieve so far? So if you look at some of the magical examples or the magical applications that we can talk about, the first one we can basically think about is autonomous driving. So several researchers across the globe have actually used this RL framework to develop self-driving cars, where the agent actually makes several decisions, such as the speed at which to go to, the areas in which it can drive to really avoid any obstacle or to stay clear from the restricted areas, and so on. These are just to name a few. But this framework has actually been very useful in actually developing some prototypes for these self-driving cars. Another common application is automated trading, where the agent gets to decide when to hold, buy, or sell various stocks, bonds, or just about any financial asset that you find in the market. But what we really want to focus on, and what the main application we are concerned about in our research, is the third one, that is to analyze attacks on blockchain incentive mechanisms. In fact, a team of researchers from different universities have actually employed this framework before to teach an agent the selfish mining strategy on Bitcoin and proof of work Ethereum. Like I just mentioned, right? Like what is this word blockchain incentive mechanisms? So almost all blockchains have what you call incentive mechanisms, which are in place to basically provide rewards for network participants who play a crucial role in keeping the network up and running. So in the case of proof of stake Ethereum, we have the Ethereum specs, which basically lays down all the rules of the protocol in order to ensure that minimal complexity is met, liveliness is maintained, that a large participation of validators is ensured, and just about a lot of these design objectives. But essentially, what would these network participants what these do with the network participants is that they are now incentivized to behave in a way that doesn't actually cause any harm to the system, but in fact does good to the system. But if you look at proof of stake Ethereum itself, which is still in its nascent stages, it's not even a year old. There are several deviations from the intended protocol, as we see here, such as these low-cost attacks on Ethereum 2.0, these ebb and flow attacks, these decoff flip-flop attacks, and so on, which actually make sense for the validators to do, since they get some positive reward out of this, rather than just being rule-abiding, law-abiding validators. So thus, what we essentially need is a system that can, one, potentially help us figure out these more complicated deviations, these more complicated attacks, and number two, provide a robust methodology for actually backtesting the protocol every time that it is updated to see if these attacks are still possible or not with the updated protocol. So if you look at the current system, and see how caveats are identified, there are roughly two steps which are involved. So the first one is intensive theoretical analysis, which is done by researchers all over the world. And once this analysis concludes, with the result being that it is actually possible to harm the network in some way or the other, which makes sense given the current protocol rules, we have a protocol upgrade that actually fixes these caveats, which basically kicks off. However, we believe that this pen and paper analysis has its own limits, and we feel that a more systematic framework and it's a more systematic approach could actually help push this further and can help push our cause further. So naturally, the next question we ask ourselves is, if we were to integrate RL techniques, right, how would attack detection now look like? And what would the resulting framework essentially be? So this is exactly what you're seeing in your screens here. So if you look at proof of stake Ethereum in general, so all the role, the entire role of the validators as well as the beacon chain can basically be reduced to this framework of an interaction between an agent and the environment. So the agent is essentially the validator in this case. The environment is, of course, the beacon chain. The various actions that the validator can do includes, sending in proposals, sending in attestations, doing nothing when it's called on to propose or attest, or propose blocks, but release it later. And there are a bunch of different actions which the agent can do. And if you look at the state, so the state that the beacon chain can provide back to the agent can be anything such as the current head of the chain, which validator is up next to propose or attest, and the balances of all validators, and essentially anything that describes the state of the beacon chain. And the rewards can be essentially anything like, the most obvious one is the earnings, since we know that the protocol rewards participants for validating and proposing on time. It can also be the number of blocks reorg if you want to see things from the lens of a person who just wants to do anything to harm the network, no matter how much harm he causes onto himself. And so there are various ways in which we can actually adopt this framework for the proof of stake Ethereum beacon chain, and this is exactly what we aim to do in our research. So before moving on, I think it would be important and relevant to introduce the beacon runner at this stage. So the beacon runner is basically an agent-based model and simulation environment of proof of stake Ethereum, which is being used to run various experiments to see how various situations would pan out according to the current rules of the Ethereum proof of stake consensus layer. So this is roughly our plan. This is where we are. This is a very oversimplified version of a roadmap, and this is essentially the state at which we are right now. So the first obvious step for us was to actually simulate the attack on beacon runner. And the second step that we also completed is to basically create a very basic GIM environment. So GIM is this OpenAI framework which can be used to build custom reinforcement learning environments. And so we actually built a very basic GIM environment with the basic proof of stake concepts, as well as a centralized client implementation of the entire beacon chain. So the next step is to basically improve this model further, decentralize the entire model, have each validator have their own view of the chain. And the final step to actually test whether or not this approach that we propose will work to, number one, detect attacks, or number two, be used in backtesting protocol upgrades, is to actually train the agent with a pre-existing attack. So we can see if the agent can actually successfully execute an attack that we know currently can work on the beacon chain. And the attack we have actually chosen for this is the attack malicious reorgs as described in Noida 2021. So that's about it from me. Thank you very much for tuning in, guys. Thank you very much for being here. You can check out the more cool stuff that is done by the Robust Incentive Group in ethereum.github.io/rig. And I hope you really enjoy the rest of EDCON. Thank you very much.